Hello all, welcome to Now You Know channel. In this tutorial, we are going to implement stack using linked list. So it is as similar as stack implementation using arrays. So unlike arrays, we will be having a chain of nodes. Basically a linked list that creates a new node, and then the new node basically it creates a new node, and current node, the current node at the point of pushing the element will be passed as a chain to the new node. So here, so we'll get into the implementation details. So here, for example, I have created a stack instance that will be holding a new empty node at the point of creating. So here we are trying to push the element to the stack, push one. So it has created a new node, and the present node is having that is pointing to that will be pointing to null will be passed as a chain. So similarly for push 2, so we are creating a new node. At the point of pushing the second element, the current node is pointing to 1, and then that is pointing to null. So every time when trying to push a new element, so we will be creating a new node, and the current node is passed to construct a chain. So similarly for 4 and 5. So on the other hand, so we are trying to pop the elements after pushing all these elements. So the first node, the latest element in the stack is 5, and then followed by 4, 3, 2, 1. So after 1, there are no more elements in the stack, so which is currently pointing to null. So it is returning null. So we are not limiting this size, unlike we did in stack using arrays. So it's up to us whether to limit our stack size, or we can let it grow, as because it is using linked list, it is a growable data structure. We are not in this tutorial, we are not putting that limitation. Adding the limited elements to the stack. So basically, we will be needing a structure to support this kind of representation. So basically, we will be needing a structure. So first, define the structure that supports this kind of representation. So I'm going to create a class node. So node that holds the data, and a chain, so that we are going to call it top. So here, if you can see, a new node is created. Okay, let it load this. Okay, a new node is created, and yes, the next chain is passed to the new node. So here I'm going to introduce a constructor, public node t data. I'm just assigning this to the respective instance variables. So that's the structure of our stack data structure. So that supports this kind of representation. So let's see what goes into those push and pop. So I have created a separate class. So first thing first, we are going to create an empty node. A node that is pointing to null, public, and this is the push logic, void push t data. Let's call this as top. So currently top is pointing to null. So when the push is called, we are going to create a new node as discussed earlier, which is currently a data, followed by this dot top. So currently this dot top is holding a null. So initially this dot top is holding null. So whenever a element is pushed to the stack, so let's it is creating a new node by the data and the current node as a reference. Fine. So this is the push logic, and for a pop, the expression to return the current element is, first of all, we need to take a backup of the data, which is this dot, top dot, data, and this dot, top dot, top equal to this dot, top dot, top. I'm pointing to the next chain. So first of all, I have taken a backup of data and I'm changing the reference to current reference chain. Fine. Finally I'm going to return the data. So here the pop, we need to check a null condition here, right? So whenever we are we have popped all the elements from the stack. So at the end we will be having a null. So for that I need to check this basic condition. If null does not equal to, let me get this one, null equal to this dot top, return null. So I'm just early returning this null whenever the top is pointing to null reference. So I'm just returning null. So otherwise I am just extracting the data and pointing the current top to current top's next chain, which is again a top. So this is the end of push and pop logic. So let's test stack linked list of type integer stack new stack linked list. So I'm going to push the elements, which is stack dot two, 3, 4, 5. Similarly, I'm going to pop the elements on the stack after pushing all this. System dot out dot println. So what I'm trying to do here is like I try to push the elements in between 6, 7. So basically push doesn't print anything in the console. So from this point onwards, let's try to interpret our output, the expectation here. So at this point the latest element in the stack is 5 and we are pushing the sixth element, 6 to the stack, so we should get 6, and after 6, so we'll be having 4 as a second latest element, so and followed by 3. So here we should be having 7 and then 2, 1. We should get null. So let's run this program. Yeah. So from this point onwards, so there is no console print to the console print when we push the elements to the stack. So from here onwards, we got the 5 and 6 and 4, 3, 7, 2, 1, again 1. Something went wrong. So let's try to find what went wrong. Okay, basically we need to, there is a 2 is pointing to, It is supposed to get the 2 at this point, but 7, after 7 it is pointing to 1 1. Okay, let's check this condition again. So null equal to let me add this. Okay, so here when pop is called, 5 6 4 3 5 6 4 3 7 1 1. So let's put a debug point here. Okay. It's a typo actually. It's a typo. Sorry guys. I thought there is a logic. There is no need to change the logic. It's actually I'm trying to push 2 times. So that is the reason we got this output. So let's rerun this program again without changing anything. So I just changed from 1 to 2 here. So like expectation is 5 6 4 3 7 2 1. 5 6 4 3 7 2 1, and at the end we are getting null. So that's the end of this video. So I hope you learned something from this video. So if you find this video helpful, please like, comment and share, subscribe. Thanks for watching. Thanks for your time. Bye.